This is math tape number 134, Rational Equations Reducible to Quadratics. On this tape we have one objective. It is to solve rational equations which can be reduced to quadratic equations. You recall from earlier work that rational equations are equations that can be written in the form of one polynomial expression over another polynomial expression. Let's review the procedure that we follow for solving rational equations. Our procedure is, first, clear fractions. To clear fractions, we multiply both sides of the equation by the least common denominator of all the fractions in the equation. Multiply both sides of the equation by the least common denominator of all the fractions in the equation. Second, we solve the equation. And finally, we omit any solutions that would make a denominator equal to 0. Let's look at some examples. Our first example is to solve for the variable x. The equation is 2 over 2x subtract 1 equals 3 over x subtract 1. We begin by determining the least common denominator. Our least common denominator must include the factor 2x minus 1. It must also include the factor x. So this means that our least common denominator is x times 2x minus 1. We multiply both sides by that least common denominator. On the left-hand side of this equation, notice that we have one term. On the right-hand side, we have two terms. Our least common denominator will multiply each term on the right. And so we get a long expression which has, on the left, our least common denominator, x times 2x subtract 1, multiplied by 2 over 2x subtract 1. On the other side of the equals mark, we have the least common denominator, x times 2x subtract 1, multiplied first by 3 over x, then subtract x times 2x minus 1 by 1. So notice that on the right-hand side we multiply both the first term and the second term by the common denominator. The common denominator is, of course, actually over 1 in each case, and so this gives us the opportunity to cancel in our fraction multiplication. On the left-hand side of the equation, the 2x minus 1 cancels. On the right-hand side, first, the x cancels, and in the second term, there isn't anything to cancel. So, considering what we've canceled and what's left, on the left-hand side we have x times 2, which is of course 2x. On the right-hand side, we have 2x minus 1 times 3, which is 6x minus 3. And finally we have x times 2x subtract 1 to be subtracted. So we have minus x times 2x, which is minus 2x squared, minus x times negative 1, which is plus x. So this gives us 2x equals 6x subtract 3, subtract 2x squared, plus x. This is a quadratic equation, and so our example is a rational equation which can be reduced to a quadratic. We've just done that. To solve a quadratic equation, of course, we must get everything on one side, 0 on the other, to write the equation in standard form. And so let's get the x squared term to the left, the 6x, the 3, and the x to the left, and the negative 2x squared added to both sides will give us plus 2x squared. We have 6x plus x, 7x to be subtracted from both sides, and we have negative 3 on the right, so we'll add 3 to both sides. This gives us 2x squared, subtract 5x, add 3. This equation is factorable. We get 2x minus 3 times x minus 1, setting each factor equal to 0. 2x minus 3 equals 0, or x minus 1 equals 0, and solving. We have 2x equals 3, which gives us x equals 3 halves, or x equals 1. Finally, in this equation, we must make certain that neither of these numbers will make a denominator equal to 0. If we begin with the 3 halves, go back to the beginning, notice that when we fill in 3 halves for x in the first fraction, we get 2 times 3 halves, which is 3, subtract 1, which is 2. That's not 0. Filling in 3 halves for x, of course, we get 3 halves. That's not 0. So x equals 3 halves is fine. X equals 1. When we fill 1 in for x, we get 2, subtract 1, which is 1. That's not 0. Fill 1 in for x, we get 1. That's not 0. And so x equals 1 is fine as well. For our second example, let's solve for the letter h. The equation is a equals 2t over b minus h. This rational equation has a single denominator, b minus h, so that means that the least common denominator that we'll use as our multiplier is b minus h. When we multiply on both sides by b minus h, we get b minus h times a equals b minus h times 2t over b minus h. Nothing cancels on the left-hand side. On the right-hand side, the b minus h cancels. And that gives us b minus h times a equals 2t. The b minus h times a distributes to give us ba minus ha equals 2t. The letter for which we're solving is h. We identify the terms which have h. Notice that h occurs only once. Here it is. So that's the letter we want to get by itself. To solve for h, we must eliminate the ba by subtracting ba from both sides. And that gives us minus ha equals 2t minus ba. To get h by itself, we'll divide by the opposite of a on both sides. Here's the h we're to get by itself, so we'll divide both sides by the opposite of a. This gives us h on the left, and on the right we'll have 2t subtract ba over the opposite of a. That's one form of the answer, but we prefer to decompose this fraction, split the fraction into two separate fractions. 2t over opposite of a, subtract ba over the opposite of a, and reduce whenever we can. 2t over opposite of a, nothing reduces, but we do prefer to have the minus sign in the numerator. Minus ba over minus a, the a's will cancel, leaving minus opposite of b, which will be plus b. This gives us h equals negative 2t over a, add b.